Alright guys, let's try to understand what are functions because they are very important in O-level mathematics, and not just that, it really is going to set up a fundamental base for your concepts in upcoming physics and mathematics that you will be learning in the rest of your life. So functions are, pretty important. So let's actually try to understand functions this way. Whenever we talk about functions, we try to perceive functions whenever we talk about some machine. A machine is something that performs a function, right? So we define machine like that. So function is related to a machine, like a fan is a machine, or a heater is a machine, or an air conditioner is a machine, or any other, mechanical thing that performs some tasks. So that is a machine. So performing a task is actually a function of that machine, right? For example, we turn the button on and the fan starts to rotate. So fan is a machine and its function is to rotate. So functions are always related to some machines, right? But there are no machines in mathematics. We're just having a paper and pen, and we're just solving some problems. Oh, where does this machine thing come into this scenario? So yes, it does come in if we think about it critically. So let's actually talk about a function machine uh, in this video. So a function machine. So if I believe if you perceive functions using the concept of function machine, it will actually make it a lot clearer for you to actually try to understand functions. So we can actually draw a machine that can look something like a box, or you can, draw a circle or whatever figure, it doesn't matter. So this is basically a function machine, right? So I'm just going to label it FM, function machine, right? You just do something to this function machine, which is called giving the input, right? So you give this function machine some input, and the function machine in return gives you an output, right? So you are giving an input to the function machine, and the function machine gives you an output. So we saw as in the example of the fan that you need to turn the button on in order to make the fan rotate. So turning the button on is the input that you're giving, and rotation of that fan is the output. So function machine always works like this. You need to give some input, and then you get an output in return. So it's a cause and effect sort of a system. In mathematics, a function could be something precisely like this, like adding 3 to whatever the input is given. So the function of this machine is to add 3 whatever the input is. For example, I can for example put, or you could just say I can just give an input of 4, and the output of that would be 7, because the function of this machine is to add 3 to whatever it is given, right? So I can add a 10, and the output would be 13, right? So just like that, I can add a, let's say I can add a -5 into the function machine, and it would give me a -2, right? So you can see whatever the input I'm adding, the output is uh, dependent on that, right? And the function of this machine is to add 3. In the world of mathematics, we have been through the concepts of algebra, and we know we can just translate any sort of information that is lying around in our everyday world. We can translate that into the world of mathematics, in the language of mathematics, via the language of algebra. So we how do we actually convert this into the language of algebra? So this is the concept of functions, the function machine. All we just need to do right now is to just convert this sort of system into the language of mathematics via algebra, right? So well, we can see that we have an input. We can, since this input is, a variable term, we can add any input. We added 4, we added 10, we added -5, we could add 128, we could add any number. So since this input is a variable, we can call this input to be x, right? Because we learned in algebra that we could just call any variable which does not have a fixed value, we can just associate it in English alphabet to that. So we associate the letter x to it. And the function machine, then what is the function machine doing? It is adding 3 to that input all the time. So plus 3. And what is it giving you in return? It is giving you in return the output. And since you can see that output is also a variable term, so we use another variable or English alphabet to represent that. So x plus 3 is equal to y. becomes an equation for us that actually represents this function system. We have an input x, the function is to add 3 into it, and then you get an output y, which is you know the result or the effect of that function, right? So x is the input and y is the output, and plus 3 is the function of the machine that it is represented, that is represented in this system here. So this y is equal to, I'm going to write it like this: y is equal to x plus 3 in more standard way. you know y represents the output, x represents the input. Whatever the input you put into it, you will get an output. So this is an example of a typical function. So the function machine, what it does is just adds 3 to whatever the variable you put as an input, and you get an output. So y is equal to x plus 3 is is a function, and you just particularly say y is a function of x. Like whatever you just the value of y you get, it is actually dependent upon the value of x, the input, and the function is just to add 3 into it. So this is the concept of a function machine, and that's how we translate information into the language of mathematics. And furthermore, we'll be discussing more complex functions and how we can relate them to our everyday life and solve problems of complex mathematics using the concept of functions.